This is question 28 in the 2013 non-calculator paper. Okay, the distance from A to B is 1/3 of the distance from A to D. The distance here from C to D is 1/4 of the distance from A to D. And the distance from B to C is 150 millimeters. What is the distance from A to D? You can pause the video and try the question. Now, to do this question, let's look at this information again. The distance from A to B is 1/3 of the distance from A to D. So this distance here is 1/3 of the whole distance. And this distance CD is 1/4 of the distance from A to D. Now we're looking at the fractions 1/3 and 1/4. When you think of those fractions, you can think so we've got 1/3 here for the first one, that this is 1/3 of the whole distance. And this second fraction, CD, is 1/4 of the distance. And I'll just move 1/4 up there. Now, when you look at these two fractions, if you can't compare them at the moment because the denominators of those two fractions are different. So we should make a common denominator between 1/3 and 1/4. Now, the lowest common denominator of 3 and 4 is 12. So we're going to make 12 the denominator of both fractions. That way you can compare the two fractions. So how do we change 1/3 into twelfths? Well, 3 times 4 is 12, so 1 times 4 is 4. And looking at the second fraction over here, 4 times 3 is 12, so doing the same to the numerator, 1 times 3 is 3. So therefore, this section here represents 4/12 of the whole distance from A to D, and CD represents 3/12. So if we've got 4/12 here and 3/12 in this section here, then BC must represent 5/12. And the way we do that is that we say, well, the distance from B to C is 1. If we consider the whole distance as 1, which is really 12/12, so I'm going to change that 1 into 12/12. So 1 whole is 12/12 minus 4/12 minus 3/12, because all the denominators are the same. 12 minus 4 minus 3 is 5. So this middle section here is 5/12 of the distance. So we're also told that in this middle section B to C that it's 150 millimeters. So we know that these are all fractions. We can really say, well, AB is 4 parts out of 12, BC is 5 parts out of 12, and CD is 3 parts out of 12. So we can say this middle section BC represents 5 parts. So we can come up with this statement that 5 parts is equal to 150 millimeters. Now, that means that to work out one part, you would divide by 5. So 1 part would be 30 millimeters. Now we need to know the distance from A to D, and A to D represents 12 parts because it's the complete length. So the distance from A to D is 12 parts, so we do 12 times 30 is 360 millimeters. So our answer is 360. Now question 29 of the 2013 non-calculator paper. This skateboard ramp is a triangular prism. Notice you've got the triangular shape here, and it's a prism because you can cut uniform cross sections of triangles all the way through this shape. It's filled with sand, and what is the volume of the sand? So you can pause the video and complete the question. Okay, now to find the volume of a triangular prism, or of any prism, first the formula is to find the volume. It's the area of the uniform cross section, which is the triangular cross section. So the volume will be the area of the triangular cross section times what we call the height of the prism. So we have to find the area of this shape, this triangle here, and then times it by the height of the prism, or how far back the prism goes. So we'll be timesing it by 1 meter. Let's first work out the area of the triangular front face. Now, area of a triangle, the formula is half times the base times the height. Here we can see that the base is 1 and the height is 0.3. So if the area of the triangle will be a half times 1 times 0.3, and a half of 1 is a half, so we just really want a half of 0.3, which is 0.15. So the area of the triangle is 0.15 meters squared. Now, to work out the volume, we multiply this area that we just found by the height of the prism. So we multiply, so volume, I'll just put that down here, is area of the cross section times the height of the prism. The area was 0.15 meters squared, and the height of the prism is 1 meter. So 0.5 meters squared times 0.15 meters squared times 1 meter is 0.15 meters cubed. So our answer is 0.15 meters cubed. And I've just shaded that answer in there. 2013 non-calculator question 30. A population of kangaroos has a death rate of 1 kangaroo every 2 days. And the same population of kangaroos has a birth rate of 1 kangaroo every 3 days. Overall, the population is decreasing at a rate of 1 kangaroo every X days. What is the value of X? Okay, you can pause the video and try the question. Now, looking back at this, if there is 1 kangaroo dying every 2 days, and 1 kangaroo being born every 3 days, it seems that kangaroos are dying at a faster rate than at which they're being born. This is why the overall population is decreasing, because a kangaroo is dying, 1 kangaroo is dying every 2 days, but only 1 kangaroo is being born every 3 days. Now, to be able to work out the rate at which the population is decreasing, we need to, because the 2 days and the 3 days aren't the same, we need to look at what number both 2 and 3 go into, and that's 6. So instead of saying the death rate is 1 kangaroo every 2 days, we want to say how many kangaroos die every 6 days. So we'll just do that here. A death rate of 1 kangaroo every 2 days means 3 kangaroos will die every 6 days. Now we're going to do the same thing here with the birth rate. A birth rate of 1 kangaroo every 3 days, well, we want to say how many kangaroos are born every 6 days. So a birth rate of 1 kangaroo every 3 days means that 2 kangaroos are being born every 6 days. So now we can see that 3 kangaroos die every 6 days and 2 kangaroos are born every 6 days, which means that overall we have 1 kangaroo, the rate is decreasing by 1 kangaroo every 6 days, because 3 minus 2 is 1. So therefore, 1 kangaroo every X days, or 1 kangaroo every 6 days, that means that X is equal to 6. Now, question 31 of the 2013 non-calculator paper. A new fence is to be built around the perimeter of this paddock. The fence, shown in this diagram, is to have 4 strands of wire, as shown. How many kilometres of wire are needed? Pause the video and try the question. Now, first thing you need to do, you might want to work out the perimeter of this entire shape. So you'll want to work out your missing sides first. This is 500 metres, that's 600, 900 and 500. We do not know the length of this side here that I'm pointing to, but if the whole length down here is 900 and this length up here is 500, then this length here will be 900 minus 500, which is 400 metres. I'm just going to put that in there. Similarly, if this length here is 600 and this one here is 500, then this small length here will be 100 metres. So I'll just put that length in there. So now you can work out the perimeter of the shape. So we'll just put that down here. So the perimeter will be 500 plus 600 plus 900 plus 500 plus 400 plus 100, as shown down here. If we add these all together, 500 and 600 is 1100, plus 900 is 2000. And if we look at these numbers here, 500 plus 400 plus 100 is another 1000. So 2000 plus 1000 is 3000. Another way you can look at this is, say, 500 plus 500 is 1000. 600 plus 400 is 1000. And 900 plus 100 is also 1000. So 1000 plus 1000 plus 1000 is 3000 meters. Now notice they're saying how many kilometers of wire are needed. We should convert this 3000 meters into kilometers, and to do that we divide by 1000 because there are 1000 meters in every kilometer. So 3000 divided by 1000 is 3 kilometers. Now, even though this is the perimeter of the paddock, the thing is that 4 strands of wire have to go all the way around the paddock. So the length of wire needed will be 4 times the length of the perimeter. So the length of wire will be 4 lots of 3 kilometers, and 4 times 3 is 12. So your answer is 12 kilometers. So I've just written 12 in there. Now, question 32 of the 2013 non-calculator paper. A teacher marked out 2 rectangles on a sports field as shown. Now we can see this first rectangle, the large one, A, B, C, D, has length 120 and width 50. And this triangle E, F, G, D, we can see its width or height, whatever, is 10. Now the 2 triangles are similar, which means that they're in proportion, that their sides are in proportion to each other. And we're also told that the distance from D to F, this diagonal, is 26 meters. You have to find the distance from F to B. You may pause the video and attempt the question. Now, what we can see, if we know that the small rectangle and the large rectangle are similar, is that the sides are in proportion. Now we have this shorter side here, ED, we know it's 10, and this side BC is 50. That means that, that the larger rectangle is 5 times bigger than the smaller rectangle. So 50 divided by 10 is 5. So the larger rectangle is 5 times bigger than the smaller rectangle. So I'll just write that down there. Now that means that the length of the larger rectangle will be 5 times bigger than the length here of EF, but it also means that the diagonal DB of the large rectangle will be 5 times larger than the diagonal DF of the small rectangle. So we're just going to put that there, that the diagonal DB of the large rectangle will be 5 times the length of the diagonal DF. Now I'm just going to draw those diagonals in as well. So there's DF in red and it's dotted. So, and diagonal DB is drawn in green. So DB is 5 times larger than DF. So DB is 5 times DF, which is 5 times 26. Now 5 times 20 is 100 and 5 times 6 is 30. So that's 130 meters. Now in the question we're looking for the distance of FB. So FB will be the distance DB, so it's the green line. Take away the red line. So FB from there to there is DB, the whole distance, minus DF. So it's 130 minus 26 because DF is 26, and the answer is 104 meters. And I've just written that answer in there. And that is the end of the 2013 non-calculator section.